In this video, we're going to look at tangent planes, specifically tangent planes to surfaces. So suppose we have a surface. Say it's given in the form z is a function of x and y. And there are some other forms that could be given to you, as we'll do those later on in another video. But suppose we have a surface of the form where you have z is equal to a function of x and y. A tangent plane at the point x naught, y naught, z naught is given by z minus z naught is equal to the partial with respect of x evaluated x naught, y naught times x minus x naught plus partial with respect to y evaluated x naught, y naught times y minus y naught. So this will give you the equation of the tangent plane. Once again, notice that this is the derivative of your function up here, evaluated x naught, y naught. The same thing here. This is derivative with respect to x, derivative with respect to y. And so it's pretty straightforward, the equation. Let's go ahead and apply it to a problem. Find the tangent plane to z equals y squared square root of x at the point 4, 2, 8. So let's go ahead and try this example. Now we're given that it's at the point on this surface 4, 2, 8, but let's just double check, be sure that this is correct. In other words, if we put 4 in here and 2 in here, we should get 8, but let's verify that. So z equals, so let's see, y was 2, x was 4. So 2 squared is 4. Square root of 4 is 2. And we do indeed get 8. So now let's go ahead. Again, if we want to use our equation for the tangent plane, we need to find derivatives. Do f of x. Remember, this means the derivative of the function with respect to x. And so let's go up here. Remember, we could rewrite this function up here is y squared x to the 1/2. Sometimes it's a little bit easier to think of it that way. And so it takes the derivative with respect to x. Remember, take derivative with respect to x, you keep all other variables constant. So bring the 1/2 in front. Y squared x to the negative 1/2. And if we want to maybe make that look a little bit nicer, we could make this 1/2 y squared. Then half is square root, and negative means it's going to go in the denominator. So it's a square root of x like this. Now remember, for our equation for the tangent plane, we're going to need to evaluate that derivative at x naught, y naught. And of course, this is x naught, y naught. So let's just put this over here. So let's evaluate it at x naught, which is 4, y naught, which is 2. And so this is going to be 1/2, 2 squared, square root of 4. And this is going to be 4 over 2. Square root of 4 is 2. Looks like that's going to be 1. Next thing we need is derivative with respect to y. Right over here. Go back to our function, derivative with respect to y. We hold all other variables constant. We have 2y x to 1/2. Or we could write that as 2y square root of x. Evaluate that at x naught, y naught. That's going to be 2, 2, square root of 4. That's 2 times 2 times 2. I guess that is 8. So now we have everything we need. Let's and just remind ourselves our equation. Like this, and so plug in all of our values. We're going to have z minus z naught, which is 8. F of x was 1. X minus x naught, which was 4. That was this part. Plus fy times y minus y naught, which was 2. And usually when you have the tangent plane, you probably want to rewrite this a little bit better. Let's go ahead and distribute this, multiply 1, multiply by 8. And let's see, let's maybe bring all the variables on one side. I'll bring all the variables to the left. So it's going to be like minus 8, minus x minus 8y plus z. And let me put all the constants on the right side. We'll have negative 20. Then we bring this over, that'll add 8 to that, so give us negative 12. Like that. And that's the equation of the tangent plane. Now, we would have got the same thing if we would have moved all the variables to the right-hand side. We would have got this multiplied by -1. So let's multiply by this by -1. Or x plus 8y minus z equals 12. So either of those represents our tangent plane Again, tangent plane is tangent at a specific point. We found tangent plane at this particular point here. Let's do one more example. Find the tangent plane to the function z equals x squared log of y. That's meant to be a ln, natural log. At the point five, 1, 0. So let's go ahead and do this. Solution. Once again, we can check, put our values in. X was 5 squared. Y was 1, log of 1. Of course, the log of 1 is 0. So we do, of course, in fact, get z equals 0. Now let's go ahead and go through and find our tangent plane. Let me take the derivative. Derivative of our function with respect to x, holding all other variables constant. 2x log y. I apologize for my log, not too clear. And again, while we're at it, you could do this now or at the end. Let me evaluate this right now while we're at it. So f of x evaluated at x naught, y naught is going to be 2 times 5 log of 1. Once again, the log of 1 is 0, so we get 0. Find the derivative with respect to y, again, holding everything else constant. So we do that, we get x squared. Of course, remember for log, you do 1 over whatever the argument is, times the derivative of that with respect to y, which is going to be 1. And let's evaluate that at x naught, y naught. That's going to be 5 squared divided by 1. That's be 25 over 1, which is 25. Once again, let's remind ourselves of our tangent plane equation. This, and then plug in our values. Z naught was 0. F of x evaluate here. This is 0. Going to make our problem pretty easy. Plus this is going to be 25. That's going to be 0, so it'll be 25. Y minus 25. Once again, you can bring everything onto all the variables onto one side. This is going to be 25y plus z equals minus 25. Or if you multiply by minus 1, you will have 25y minus z equals 25. Either of those represent the tangent plane. And of course, it's always a tangent plane at a specific point. Let me just write that down at the point 5, 1, 0.